It's your friendly math tutor, Miss C here, and today we are practicing function notation. Our first problem says the function f is defined by f of x equals 9x minus 5, and we are asked to find a series of values. So our first problem that we are tackling is we are to find f of 4. So you're going to notice here that I'm reading this f of 4, not f multiplied by 4. This is the function notation. What this means is everywhere I see x, I'm substituting 4. The reason I know that is the 4 replaced the x. So if you look at f of x up here, you can see that where the 4 is where x is. What that tells me is I'm trying to find the value of f of x when x is 4. So let's go ahead and do that. So I'm going to write f of 4 equals 9 times 4 minus 5. So you're going to notice everywhere there was an x, I replaced it with 4. So let's go ahead and solve this. So we end up with f of 4 equals 36 minus 5. I'm just simplifying the right side of the equation, and I get 31. The f of 4 doesn't move. That's like your y value. It just is telling me that when I put 4 in for x, I get out 31. So the reason this notation is nice and useful is that it tells me what my input is, which is x, and what my output is, which is y. So the benefit is it clearly allows you to see, keep your work organized. So that's the point of this. Our next problem is f of negative 2. That's what we're finding. You guessed it. Everywhere we see x, we're plugging in negative 2. And then we're seeing what we get out for y. So I'm not going to keep rewriting f of negative 2 right now because I'm just going to do my equal sign. And we know in math that means we're solving the same thing. So when I do that, I get, in my final answer, I'm going to write this, f of negative 2 equals negative 23. That means when x is negative 2, y, my y value, or my f of negative 2 value is negative 23. All right, our last problem. Ooh, this is different. I'm looking at where I've been finding a new number, and I see x. So what that tells me is I need to look at this again because look what happens. It says f of x equals 67. If I come up to my function here, I see f of x right there. 67 is our y value or our output value. So what we're going to do is we're going to substitute 67 in everywhere we see f of x. We're replacing the entire thing, not x. So we say 67 equals, and now we are going to say 9x minus 5, and we're actually finding the x value. So I'm going to go ahead and add 5 to both sides. I get 72 equals 9x. I'm following the order of operations working backwards. So I did the addition and subtraction. Now I'm doing the multiplication and division. I'm dividing 9 off, and I get x equals 8. So what I know is when x equals 8, f of x or y equals 67. All right, let's take it up a notch. Those were linear functions. Let's look at a function that's not linear. So we have function g, which is defined by g of x equals x cubed plus x squared minus x, and we are finding g of negative 3. So I'm going to just highlight everywhere I see the x value that I am replacing. So everywhere I'm going to be putting in negative 3. So I'm replacing g of x with g of negative 3, and that tells me everywhere I see x, I'm plugging in negative 3. Here's what's tricky about this when you've got exponents. Your x value has to go in parentheses because the whole x value is getting raised to the power of 3. And now it's getting raised to the power of 2. If we don't put the parentheses, the parts that need to be cubed or squared, they drop off. So for example, in this problem, if we want to look at this separately, I've got a negative times a negative times a negative. That means I'm going to get a negative number out. So negative 3 cubed is negative 27. But negative 3 squared, a negative times a negative is positive, right? Negative 3 times negative 3 is positive 9. So do you see how if I don't have those parentheses, I could potentially end up with the wrong sign and then the wrong answer. And then I have minus negative. Two negatives make a positive, so I'm adding 3 here. So I have negative 27 plus 9 plus 3. That's really negative 27 plus 12. And that gives me negative 15. So G of negative 3 equals negative 15. So I know that when I put negative 3 in for x, I get negative 15 out for y. All right, here is our last problem. Again, another nonlinear problem. I'm noticing that I have x's here and here and here. And I'm going to read our function. It is defined as m of x equals 3x minus 1, all divided by 4. And we are finding m of x. Okay, so we're not finding x. Oh, we're finding m of x. I guess that color of highlighter doesn't work. So everywhere we see m of x, I am substituting in 11 right here. So I'm solving for x one more time. So 11 equals, so remember I replaced all of m of x with 11, 3x minus 1, and I am solving for x. I'm going to start by getting this fraction out of my denominator. I'm going to do the opposite of dividing, which is multiplying. Okay, when I do that, I get 44 equals, this becomes a 1, 3x minus 1. And now I'm continuing to follow the order of operations. Now that I've got that fraction out of the denominator, I'm going to add 1 to both sides, which gives me 45 equals 3x. Divide by 3 on both sides, and x equals 15. So what we know is that when we put 15 in for x, we get out a value of y that equals 11. Make sure to subscribe for more math videos. Till next time, remember, you've got this.